Hi everyone, welcome to today's class on matter in our surroundings. We will be discussing about the change of state. Change of state means change from one state of matter into another state of matter. That means from solid to liquid, liquid to gas, and vice versa. We will also be discussing about what happens when the change of state takes place. So, what is the change that takes place in the matter when one state changes into another? And we will also be discussing about latent heat of vaporization as well as latent heat of fusion. Latent heat of vaporization and latent heat of fusion. Now, before we discuss all this, let us first take a look at an experiment. In this experiment, we will be heating a little water in a beaker. A thermometer will be kept inside the beaker. We will observe how the temperature rises as we heat it. So we will be seeing the level of mercury in the thermometer. As we heat it. So let us take a look at the experiment. You can see a heating coil and little water is kept in a beaker and there is a thermometer inside. Now you can see the level of mercury in the thermometer. You can see the appearance of a little vapor on the surface of water, and level of mercury is slowly rising. So keep observing it very minutely. You can see a little more vapors on the surface, but water hasn't started boiling. So level is still rising. It has reached almost at 100 and water started boiling. So now the level is at 100, water is boiling. We keep heating it, but you can see now the level does not rise further, it remains at 100. So we will be explaining all these observations. So what are the observations we made? The heat is supplied to water, temperature increases, but it increases only up to 100. Beyond 100, even if we heat it, it does not rise. Water boils at 100, but beyond 100, the temperature does not rise, even if we keep heating it. So these are the observations we made. So think, why is it so? We are heating means we are supplying energy, right? So this energy is absorbed by the water taken in the beaker. So if the energy is absorbed, where is that energy going, or for what this energy is being utilized. So it is used for something. What for is this energy used for? Think and try to find out an answer. Energy is absorbed, that is why the temperature is rising. So for what purpose that energy is being used for? In water, as we studied already, there is attractive force between the particles of water. So if you consider one particle is surrounded by many other particles, in between each particle there is attractive force. Now the heat that we supply is absorbed by water. So what happens is the heat is used for vibrating these particles at its own places. They will not be able to move from their places till we break the attractive force completely. But as it is vibrating, it must be reducing the attractive force. And at 100 degrees Celsius, these attractive forces are completely broken. And when the attractive forces are completely broken, they come out in the form of vapor. It's a liquid because of this attractive force. So when it boils, what it means is at the boiling point, these water particles become vapor. That is why you see bubbles inside, and those bubbles are actually the water vapor. So at the boiling point, the kinetic energy of these particles can completely overcome the attractive force present between the particles, and it come out in the form of vapor. This is what happens when water boils. So we have to answer this question now. After 100 degrees Celsius, even if we keep heating it, the temperature does not rise. And what is the reason? Up to 100, you have observed that the temperature is increasing. But after 100, temperature is not increasing even if we keep heating it. Yeah. Think and find out an answer. Why the temperature is not increasing beyond 100 degrees Celsius. So what it means is, once water starts boiling, further heating will not increase its temperature. Does it mean that we cannot make water boil at a temperature more than 100? Let us try to understand this. What happens is, this temperature we supplied is being utilized to break the attractive force after 100. Up to 100, all the temperature we have supplied is hidden in the system. It is used to break the attractive force once it reaches 100. So heat we supplied is utilized for breaking the attractive force. Therefore, the temperature does not rise. But up to 100, the temperature we supplied is used for vibration of the particles. Now let us try to understand this boiling point properly. At 100 degrees Celsius, water boils. What exactly is boiling point? There is a very, very important condition here. If you define boiling point without mentioning that condition, you will go wrong. The condition is water boils at 100 degrees Celsius if the atmospheric pressure is 1. The unit of atmospheric pressure is atmosphere, so we call it 1 atmosphere pressure. So if you define boiling point without mentioning the atmospheric pressure, it will be wrong. So does that mean that by changing the atmospheric pressure, if we can change the atmospheric pressure, the boiling point also will change? That's what. We can make water boil at a temperature 90 degrees Celsius, at a temperature 70 degrees Celsius. Maybe you can make it boil at a temperature more than 100 also. You can make it boil even at 500 degrees Celsius. So that means the boiling point depends on the atmospheric pressure. So try to understand this very, very clearly. If you define boiling point without mentioning the atmospheric pressure, it will be wrong. So what is the condition? Water boils at 100 provided atmospheric pressure is 1. If it is not 1 atmosphere, it will not boil at 100 degrees Celsius. Now let us try to understand this latent heat of vaporization properly. Suppose we have 1 kilogram of water. We are keeping it at 1 atmosphere and we heat it. And if we convert this entire 1 kilogram of water into vapor, how much energy will be required? Since it is energy, the unit will be in calories or kilocalories. So we are converting 1 kilogram of water completely into vapor, and we are trying to find out the total amount of energy required. And if you can measure it, you will find that energy equal to 540 calories. And this energy is called latent heat of vaporization. So how would you define latent heat of vaporization? It is the amount of energy required to convert 1 kilogram of water completely into vapor. Same way we can define latent heat of fusion also. So you can see it comes in calories or can be kilocalories also. This will be the unit. So what will be latent heat of fusion? Same way, you have to take 1 kilogram of ice, find out the amount of energy required to convert 1 kilogram of ice completely into liquid water, and the amount of energy required is 80 calories. Therefore, latent heat of fusion of ice is 80 calories. You can see this figure. You can see ice getting converted to water, water getting converted to water vapor. Now, when water is getting converted to water vapor, you can see the temperature is remaining at 100. Once the boiling starts, the temperature does not rise. So it is at 100 degrees Celsius. And the amount of energy which is required is 540 calories, and there is a change of state. Similarly, you can see on the left hand side, for the conversion of ice into water, this will happen at its melting point, 0 degrees Celsius. The total energy required is 80 calories. So we have learned two important definitions: latent heat of vaporization and latent heat of fusion. That's all for today's class. Thank you. See you in the next class.